A little over 300 years ago, an apple fell from a tree and changed the world forever. Well, not really, but the fall of that apple did inspire Isaac Newton to develop his theory of gravity, a theory that would change the world forever. If he hadn't come up with that theory, we wouldn't have had space travel, GPS, satellites, or iPhones. And we'd probably still think that the sun goes around the earth. So let's take a moment to thank that apple. But today, we're going to talk about something that would make even Sir Isaac scratch his head. Let's talk about a black hole. More specifically, let's talk about the physics of black holes because there is some stuff going on down there that AI are normal. Like, for one thing, it's impossible to observe the inside of a black hole. Once something crosses the event horizon, it can never escape, and we can only observe things by seeing the light they emit. So once something crosses the event horizon, we don't know what happens to it. We just know that nothing can get out. For another thing, the inside of a black hole is not empty. In fact, it's the exact opposite. It is filled with all of the stuff that got sucked in by the black hole and now resides at the bottom of it. But this stuff isn't just sitting there passively. Everything inside a black hole is moving extremely fast. There are atoms, molecules, stars, planets, black holes. All of these objects are moving so fast that they form a kind of soup. This soup is called a singularity, and it's located at the center of every black hole. And finally, the most mind-bending thing about black holes is that they actually break the laws of physics. Here's why. One of the fundamental laws of physics is that nothing can travel faster than the speed of light. But inside a black hole, things do exactly that. That's because the fabric of space-time is stretched so thin inside a black hole that it becomes transparent. And when something is traveling through transparent space, it doesn't have to obey the usual rules. It's like trying to walk through a wall. If you were outside the wall, you'd be stopped dead in your tracks. But if you were inside the wall, you could keep going indefinitely. That's because inside a black hole, the fabric of space-time is so stretched out that it loses all rigidity. It becomes completely flexible, so anything can happen inside a black hole. So what would you experience if you fell into a black hole? Well, first of all, you wouldn't feel anything at all. That's because a black hole doesn't have any sharp edges. It's not like falling off a cliff. Instead, it's more like walking towards a wall. You don't feel anything until you actually hit the wall. And that's because the force of gravity near a black hole is extremely weak until you get very close to the event horizon. Once you cross the event horizon, though, everything changes. You see, inside a black hole, gravity becomes infinitely strong. And the reason for that is pretty simple. That's because a black hole is basically a giant ball of compressed matter. All of the stuff that has been sucked into a black hole is sitting at the bottom of it, and that means that there's a lot of mass packed into a very small space. According to Newton's theory of gravity, the strength of gravity depends on two things: the mass of an object and the distance from that object. The further away you are from an object, the weaker the gravitational pull. But a black hole is so dense that it makes its own gravity infinitely strong. That's why crossing the event horizon is like walking into a brick wall. You are met with an infinitely strong gravitational force that pulls you towards the center of the black hole. Once you cross the event horizon, you're trapped forever. Nothing can escape a black hole, not even light. That's why it's called a black hole. It's black because no light can escape. So once you're trapped inside a black hole, there's no hope of escape. You'll be pulled towards the center of the black hole and eventually get crushed. But wait a second, I hear you saying that's all well and good, but I don't actually want to fall into a black hole. And fair enough, that was a little dramatic. But what if you didn't fall straight into a black hole? What would you experience if you just sort of grazed the edge of it? Well, if you were to graze the edge of a black hole, you would experience something called spaghettification. And yes, it's as horrible as it sounds. That's because as you graze the edge of the black hole, the gravity on one side of your body would be much stronger than the gravity on the other side, and this would stretch your body out like a piece of spaghetti. It would literally pull you apart atom by atom. And then once you were stretched out, you'd be pulled into the black hole and crushed to death. But maybe you're rethinking your Rhea Smart Alec and you're re-gone not foil my plans by saying, well, actually, I wouldn't experience any of that because time stops at the event horizon anyway. And I'll admit that you are correct. Time does stop at the event horizon. That's because the event horizon is the boundary between two regions of space-time. On one side of the event horizon, time flows normally. On the other side, time stops completely. It's like if you were standing at a train station watching a train approach. As the train approaches, time seems to slow down. That's because as the train approaches, the light from the front of the train gets stretched out. And the reason that light gets stretched out is because space itself is getting stretched out. As space gets stretched out, the wavelength of light gets longer, which means that the frequency of light gets lower, which means that time slows down. So if you were standing at a train station watching a train approach, time would seem to slow down. And if you were on the train, time would pass normally. If you were on the train, you wouldn't notice anything unusual happening. But to the observer standing at the train station, it would seem like time on the train was slowing down. And the closer the train got, the slower time seemed to go. Well, something similar happens at the event horizon of a black hole. As you approach the event horizon, space itself gets stretched out, which stretches the light that you see. And this stretching of space causes time to slow down. So as you approach the event horizon, you would notice that time was slowing down. And once you cross the event horizon, time would stop completely. But here's the kicker. Time wouldn't stop just for you. It would also stop for everything else in the universe. That's because the event horizon is the boundary between two regions of space-time. Once something crosses the event horizon, it can never escape. And that means that once you cross the event horizon, you're cut off from the rest of the universe. You're in your own little bubble where time has stopped. Now, if you were a religious person, you might find this a little unsettling because it basically means that God is actually a black hole. I mean, if time stops at the event horizon, then that means that God must be beyond the event horizon. And if God is beyond the event horizon, then he's trapped forever and he can never come back. But hey, I'm just a science guy, not a theology guy. Anyway, the point is that if you were to fall into a black hole, you wouldn't actually feel anything because time stops at the event horizon, but that doesn't mean that you'd be safe. Falling into a black hole would be incredibly dangerous. You'd be met with an infinitely strong gravitational force that would pull you apart atom by atom. You'd be stretched out like a piece of spaghetti and then crushed to death. So falling into a black hole would definitely be a bad thing. And unfortunately, there's nothing you could do to prevent it. Even if you were able to escape the gravitational pull of the black hole, you wouldn't be able to get away from the radiation. Black holes emit a type of radiation called Hawking radiation, and this radiation is incredibly deadly. It's basically a bunch of high-energy photons that get emitted from the edge of a black hole. And these photons travel at the speed of light. So if you were to fall into a black hole, you wouldn't be able to escape the radiation either. You'd be cooked alive from the inside out. So falling into a black hole would be a horrible way to go, but it wouldn't be the end of your story. Once you were cooked alive, you'd become part of the singularity at the center of the black hole. You'd be crushed to death, and then your atoms would be scattered throughout the universe. And then some poor sap would come along and fall into that same black hole, and you'd get to do it all over again. So yeah, falling into a black hole wouldn't be fun. In fact, it would be downright terrifying. But hey, if you ever do fall into a black hole, just remember one thing, it could have been worse. You could have fallen into a black hole that had already consumed an apple tree. Now you need to watch Physics Explains Why Time Doesn't Exist. Or check out what actually is a black hole.